chemistry students, welcome back to week 6 of distance learning. We are in the final stretch. Congratulations, because you guys have made it through T3. I know that that's not easy. This has not been an easy feat, and I just want to take a minute and say that I am really, really proud of you. Even if you haven't been able to complete every single assignment, as long as you are communicating with me and letting me know what's going on, then thank you. And that's all I need from you guys at this point. This week, we are wrapping up our unit on chemical reactions, and we're going to talk about what's known as the collision theory and kinetics. And then starting next week, we're going to move on to our final unit for the year. Just a reminder, this is not summer school. I saw that some of you guys put down that you were tired of summer school. Summer school doesn't start until June. This is still regular school, so please make sure that you are keeping up with the work. If you're unable to, make sure that you are sending me an email so that I at least know what's going on. If you are struggling in any way, please feel free to reach out to me or reach out to somebody and talk. I understand that this is a very stressful time. This is not what you guys expected at the beginning. And I just want to let you guys know that I'm here for you if you need it. So before we begin, you're going to need the following materials. You will need the kinetics notes that are posted on week 6 on Canvas, a writing utensil to take notes, and of course your chemistry notebook. By the way, if you left your chemistry notebook in the classroom before we left, it is still there. So when you go back to school in August, please stop by, say hi, and pick up your notebook and put all of the stuff from distance learning in there. So what we're talking about with collision theory is how effective a reaction will be. So if I were to take two things and mix them together, a reaction will not necessarily take place. And so we're looking at what's called effective collisions, because a reaction will only take place if we have effective collisions between particles. In order for an effective collision to take place, there are two things that are required: the right amount of energy and the right orientation of particles. So before we go any further, I'm going to give you guys an example. Let's say, for instance, I'm looking at a chemical reaction and clapping my hands together is the chemical reaction. So when you hear this sound, a chemical reaction has occurred. But it may not necessarily take place. For instance, if I were to bring my hands together, but I'm slow, which doesn't require as much energy, so I'm slow about bringing them together, do you hear that sound? That means that a reaction did not occur. Let's look at another example. If I were to bring my hands together, but one of my hands is like this, do you hear that sound? So the only way we'll hear this sound, so the only way a reaction will occur is if I bring my hands together fast enough, so with enough energy, and they're both facing the correct way. So when I'm talking about the right amount of energy, energy is required to break bonds. And so in order for new particles to form, so for products to form, the pre-existing bonds from the reactants need to break. So collisions must have enough energy to break these pre-existing bonds. And this amount of energy is known as activation energy. If you take a look at these examples, you'll see that the activation energy is right here at this peak. So in all of these examples, the amount of energy it takes to reach these peaks, that's the activation energy. That's the amount of energy required to break these bonds. I thought these were interesting graphics because this actually demonstrates how endothermic versus exothermic reactions occur. So if the amount of energy actually is more in the products versus the reactants, then this is known as an endothermic reaction. Whereas if the amount of energy from the reactants is higher than the products, so that means energy is released, that means that it is an exothermic reaction. I just thought that was pretty cool. The second condition for an effective collision to take place is the correct orientation. So remember I said that if I were to try to make a sound like this, it won't happen. The collisions must occur with the molecules in the correct orientation. So the example that I have here are with magnets. If you have two magnets and you're trying to bring them together, if you have both north poles facing the same way, they're not going to collide together. However, if you have a north and a south pole and bring them together, then they will bond. Now that you guys have a basic understanding of how collision theory works, I'm going to talk to you specifically about the study of kinetics, which is the study of the speed, how quickly a chemical reaction takes place. So the speed of the reaction is also known as the rate of the reaction. And when we talk about reaction rates, the reaction rate is equal to the frequency of effective collisions. So the more the molecules effectively collide, remember correct orientation and amount of energy, the higher the reaction rate will be. I do want to make a note that when we talk about activation energy, there's something known as a catalyst, which can in fact lower the activation energy. So please take a look at this infographic. So when you add a catalyst, you should notice that the activation energy decreases. And so it doesn't require as much energy to go over and to cause an effective collision. There are 4 factors that can affect the reaction rate, aka the frequency of effective collisions. These factors are surface area, concentration, temperature, and finally the last one, which I just mentioned, whether or not there is a catalyst in place. So with this first example, with surface area, the first thing you need to understand is surface area is not the same thing that you learned in math class. It's not length times width or pi r squared. Surface area is not how big something is. When we talk about surface area in chemistry, it refers to the area of contact between reactant particles. So you can increase the surface area by breaking particles into smaller pieces. And when you do that, this actually creates more exposed areas within that particle for the collision to occur. So I'm going to show you what I mean by this. Let's say that we have a seltzer tablet, which is what you put in water to make it all fizzy. And so we start off with one seltzer tablet. Well, right now, this one seltzer tablet, when it immediately comes in contact with water, the water is only touching the outside of the tablet. However, let's say that we then break the seltzer tablet in half. When we do that, and then we put it in water, then the water is coming in contact with these middle edges as well. Therefore, we have increased the surface area because the water is coming into contact with more of the seltzer tablet because it's coming in contact with what was originally part of the inside over here. And now let's say we take this and we break those into half. So now, once again, the surface area has increased because water is coming into contact with more pieces. And ultimately, if we were to smash this into pieces, we could see that the surface area has increased drastically because look at all of these outside pieces now that the water can come in contact with. Originally, that was all on the inside, so the water wouldn't have come in contact with it. But by breaking them up into these really, really, really tiny pieces instead, Water is able to be exposed to more areas, therefore the surface area has increased. The smaller the particles, the greater the surface area. The second factor that I'm going to talk to you guys about is concentration. So let's say that I've decided to make Kool-Aid. Well, I can make Kool-Aid in different concentrations. So here are 5 examples of concentrated Kool-Aid. This is the least concentrated, so we call this the most diluted, whereas this is the most concentrated. And so what concentration is it's the number of particles in a defined volume. For example, all of these have the same amount of water in them, however, they have different amounts of Kool-Aid in them. So this has the fewest amount of Kool-Aid particles, therefore it has the smallest or least concentration. This has the most Kool-Aid particles, therefore it has the greatest concentration. And the higher the concentration is, the more collisions will occur because there are more particles within it, so they're colliding more. The third factor is temperature. Raising the temperature increases the kinetic energy, and this causes faster reactions for 2 reasons. The first one is it just allows for more collisions in general because we learned from gas laws, the higher the temperature, the more the particles are moving around. But more importantly, they allow for more effective collisions because each collision is occurring with more force. And so if you look at this graph, you can see that the lower the temperature, the more energy it takes to move around and therefore cause these collisions. However, the higher temperature actually requires less energy because they're moving around more. This last example, catalysts, is actually something you guys have heard before back when you were in honors biology. So hopefully this graphic looks familiar. When we talked about catalysts in biology, we talked about them in regards to enzymes. In chemistry, when we talk about catalysts, we talk about them in terms of speeding up reactions. So an enzyme is a type of catalyst. And what's important about catalysts is they lower the activation energy needed for a reaction to occur. So for instance, let's say that you're pushing a wheelbarrow with dirt up a hill. If you don't have a catalyst, it's going to take a lot more energy to get up this hill. However, a catalyst basically lowers that curve, so it does not require as much energy. What's important to note is catalysts are not reactants. They're not used up as the reaction occurs, and they can actually be reused over and over again. So for instance, you have a catalyst, and you can have 2 things bond to the catalyst. This lowers the activation energy, and when it's done, your 2 reactants, now products, are released from the catalyst, and the catalyst can then move on to another reaction. This is actually everything we need to know for this unit. Before we move on to testing your knowledge, I do have a joke of the day for you. What does a cat need to do the shopping quickly? A cat-list, get it? Just a little humor, you know. So I'd like you guys to pause this video for a few minutes and take the time to fill out this chart on your own. When you're ready, hit play and we will begin. In 3, 2, 1. So when we talk about a reaction rate, we mean how quickly the reaction occurs. If we were to increase the surface area, aka decrease the particle size, then the reaction rate will actually increase, so we will have more effective collisions. If we were to increase the concentration, once again, the reaction rate will increase. If we were to increase the temperature, the reaction rate will increase. Are you guys noticing a pattern? And if there is a catalyst present, that will lower the amount of activation energy needed to break the bonds. Therefore, it will increase the reaction rate. So that's all I have for this topic, guys. Please make sure that you check out the Kinetics worksheet that goes along with the notes, and please complete the Kinetics lab for this week. Remember that I'm here if you have any questions. You can reach me on Remind or via email. I'm still trying to do regular office hours. Please ask me if for some reason you can't find me on Zoom. I am having some internet issues, but I am doing my best. Happy studying, guys. I love you all, and I miss you very much. Please stay safe out there. Bye.